electric charge. So what are the topics we are going to discuss over here means what is meant by electric charge and the types of charges and properties of charges and classification of materials and unit of charge and quantization. Quantization in the sense we are going to calculate how many number of charges are there going to be in one electron. So first, what is meant by electric charge? So electric charges are considered as the fundamental property of matter. So these charges will experience a force when it's placed in an electromagnetic field. What type of force it will experience means either an attractive force or a repulsive force. Either an attractive force or a repulsive force. So based upon the values or the charges, we are going to divide the charges into two categories. One it is called as the positively charged particle and another one is called as the negatively charged particle. Positively charged particle is nothing but called as the protons and negatively charged particle is called as the electrons. And the magnitude of proton and electron is 1.6 into 10 to the power of minus 19. And the magnitude of electron is going to be minus 1.6 into 10 to the power of minus 19 coulomb. These two values we need to remember. In order to calculate the quantization of charge, we'll be using that formula. Quantization of charge in the sense we'll be using the formula as Q is equal to N into E. In the place of E, we'll be substituting this value over there in order to find the number of charges. So N is equal to Q by E. The value of E, it is a constant that is also called as the magnitude of the electrons. So what is the magnitude of electron? 1.6 into 10 to the power of minus 19 coulomb. Next, the properties of charges as I said earlier. Like charges will repel each other whereas unlike charges will attract each other. So what is the meaning of the word like charges means the same charges. That means a positively charged particle is kept closer towards a positively charged particle or a negatively charged particle is kept closer towards a negatively charged particle means by that time the two charges will repel each other. That means the two charges will move away from each other. The two charges will repel. And unlike charges means that different charges. That means a positively charged particle, that means a proton, is kept closer towards a negatively charged particle. That means an electron. So by the time what will happen means the two charges will move closer towards each other. That states that the two charges will attract. So from this you can say that like charges will repel each other whereas unlike charges will attract each other. Next, based upon the movement of the charges, we are going to divide the material into two categories. One is called as conductor and another one is called as insulators. So first, what is meant by conductor? So what are the materials which allows the current to pass through them? For example, in the electrical devices and all, we will be using the copper wires, right? So this copper wire is considered as a conductor. So why is going to act as a conductor means because the copper wires will be having more number of free electrons will be there. So that is the reason conductors are allowing the electric current to pass through them. One of the important question, why conductors are allowing the electric current and why not the insulators? Conductors will be having more number of free electrons whereas insulators, it does not have any free electron. So that is the reason insulators are not allowing the electric current to pass through them. So what are the examples of insulators is wood, plastic, rubber. Next, unit of charge. Since charge it is a measurable, we need to know what is the unit of charge. The unit of charge is coulomb and it is represented by the symbol C. So whenever you are going to calculate any magnitude or else any quantity, for example, suppose if you are calculating charge. So after calculating, next to the magnitude, we need to write the unit. So without unit, if you are writing any quantity means they'll reduce a mark. Half mark will be deducted for each unit. If you are not writing, so unit is mandatory. So what is the unit of charge? The unit of charge is coulomb. And this one is named after the scientist Charles Augustine de Coulomb. So in exam, no need to write this and all. You just write the unit alone. So what is the unit of charge? The unit of charge is coulomb. Next, quantization of charge. As I said earlier, quantization is nothing but called as the number. So you are going to calculate how many number of electrons are there in 1 coulomb of charge. In 1 coulomb of charge, how many number of electrons are there? 6.25 into 10 to the power of 18 electrons. So how many electrons are there? 6.25 into 10 to the power of 18 electrons. This value we need to remember. They'll be asking in 1 month, find how many electrons are there in each coulomb of charge or 2 coulomb of charge. Suppose if they're asking for 2 months, directly you can multiply this 6.25. 2 into 6.25 into 10 to the power of 18. This value anyway it is going to be the same. Clear? For each coulomb, how many number of electrons will be there means 6.25, it is a fixed value. If they're asking for 2 coulomb, 2 into 6.25. They're asking for 3 months, 3 into 6.25 into 10 to the power of 18. So these two numbers only we need to multiply. Clear? For example, 3 into 6.25. So initially no need to consider the decimal and all. Just multiply these numbers. 5 3s are 15. Balance is going to be 1. 2 3s are 6. 6 plus 1 is going to be 7. 6 3s are 18. So now find how many digits are there after the decimal. 1, 2. So from the right, after 2 digits, keep the decimal place. Then how I can write? N is equal to 18.75 into 10 to the power of 18 electrons. So the same procedure only we are going to follow for 4 coulomb or 5 coulomb or 6 coulomb, whatever it is. The main thing, this value we need to remember. So how we got that value? We can calculate that one. So first the question is in, calculate the number of electron constituting 1 coulomb of charge. That means in 1 coulomb of charge, how many number of electrons are going to be there? So by using the quantization of charge formula, Q is equal to N into E. Here we are going to find N value only. So N is equal to Q by E. If you are having any confusion in rearranging the formula, remember in a form of a triangular method. So Q, N, E. If it is nearby each other means it states that it is multiplication. If it is one above the other means it states that it is division. So here we need N. Hide the letter N alone. Remaining 2 letters you can able to see. One is Q and another one is E. Both are located one below the other. That states that it is in a form of a division. So N is equal to Q by E. Now substitute the value. N is equal to, what is the value of Q over here? 1 coulomb. So 1 C by, what is the value of electron? 1.6 into 10 to the power of minus 19 coulomb. So coulomb can cancel each other. Remaining what will be then? N will be equal to 1 by 1.6. Now take the 10 to the power of minus 19 to the numerator. It will change into plus 19. So therefore, N will be equal to 1 by 1.6. So in order to reduce the decimal place, what I am going to do is I am going to multiply and divide by using 10 into 10 to the power of plus 19. So 1 into 10 is going to be 10 by 1.6 into 10, 16 into 10 to the power of plus 19. If you are simplifying these two numbers, 5 2s are 10, 8 2s are 16. Go along the normal long division. 5 by 8. Since 5 is smaller than 8, we can add a 0 and keep a decimal place. 6 8s are 48. Balance 2. Add a 0. 2 8s are 16. Balance 4. Again add a 0. 5 8s are 40. Balance 0. So what is the final answer over here? N is equal to 0.625 into 10 to the power of plus 19. But in the previous I said that N will be equal to 6.25 into 10 to the power of plus 18. So what we did means we split the power into two parts. So having split this one, n is equal to 0.625 into 10 to the power of 1 into 10 to the power of 18. We are splitting like this means. As per the exponent rule, if base is common, we can add the powers. 18 plus 1, again it's going to be 19. So there won't be any change. So now what we are going to do means, we are going to multiply this alone. So what are the numbers are they? 0.625 into 10 to the power of 1. 10 to the power of 1 is nothing but called as 10. So now 0.625 into 10, 6.25 into 10 to the power of 18 electrons. So how many number of electrons will be there in each coulomb of that? 6.25 into 10 to the power of 18 electrons. This anyway it is going to be same. So you just memorize the values alone. Yeah.